So I'll start today's class by just talking generally of a complex function. Okay. Now, if you look at this, this is the complex variable. Every time we'll be talking about complex variable, it is always in Z. And as far as this course is concerned, we have two types of complex variable. We have the Z and we have the W. Each of these, so far we call them as complex variable. I said they must relate to two real variables. So if this is Z, it relates to the first real variable, which is X, and relate to the second real variables, which is Y. Both X and Y, they are real variables. Then we have Z, which is a complex variable. The what is linking them is this I, and this I has its own definition. If you have the square of I, it gives you -1. It therefore implies that what is I? What is I? Let me take, for example, um, let me say, find the root of -4. What is this answer? Are you with me?
Yes, sir.
Yes, sir.
What is this answer? This answer is the root of -1 times the root of 4. And what is this? This is I. This is what? Plus or -2, right? So this automatically is plus or negative uh, I 2. Are you getting me?
Yes, sir.
So generally, what is I? I is equal to the root of what? -1. So if I ask you to find the root of -16, then complex functions or complex variable is very, very important. This one will give you plus or negative I 4, right? But if you go to secondary school, they will tell you that, or if you press your calculator, you say root of -16, you say error. But complex will tell you that it's not error. Is that clear? Now, we have, this is a complex variable, and that is defined in this form. We have another second complex variable, W, which is also defined in terms of two real, U and V, where U and V are real variables. Okay? Then there is something that is important. How do we relate this Z and this W such that we say one belongs to another? We say if there is a relationship between W and Z in such a way that each value of this Z in a given plane, each value of this Z in a given plane is assigned one and only one value of W. That means in each value of Z is assigned one value of W. If that is the case, then we say W is a function of Z. So what do you mean by saying W is a function of Z? It means that each of the value of Z is assigned a value of W, or each of the value of W is assigned a value of Z. If that, so in this case, we can say, okay, if we say W is a function of Z, then this is how we can write it. Now, let's take, for example, consider this function. W is equal to what? Z squared minus Z. Now, in this function is defined, this function is defined for all values of Z. There is no value of Z you put here that this function will be undefined. If you like, you put 0, 0 is a real number. 0 minus 0 is 0. If you like to put -1, it is going to give you a number. If you like, everything will give you a number. There's no way this function will be undefined. So we say it's defined for all values of Z. Okay. Therefore, what we have in the right hand side, okay, can be computed in the form of Z. Now, if you are with me, whenever you see Z from today henceforth, as far as this course is concerned, always replace it with X plus I minus Z. I mean I minus Y. anytime you see Z, this Z, okay, if you want, you must replace it with this. Anywhere you see W, you must replace it with what? U plus what? IV. Very, very important. So if you look at this now, we say this is defined for all value of this, okay? Show that W is a function of Z. Simple. For you to show that, then what are you going to do? This is, we know that W is this, right? So if W is this, then we can take, you see, this is W, right? This is W. Then this is Z. We take the Z square minus Z. So we just open this, and this is W. So this is how we do it. We replace W here, we replace Z here, we replace Z here. Then when we open everything, we now take both the imaginary and the real. This equation has, this section here is referred to as the real, while this section here is referred to as the imaginary. Okay? This side is referred to as the imaginary, while this side is referred to as the real. So when you open this bracket, you make sure that you take all the imaginary one side and then you take all the real one side. So in that case, when we talk about the real side
Okay.
has nothing to do with the I. Anything that does
Okay,
not
sir.
contain I is the real. Anything that contains I is the imaginary. Is that okay?
Yes, sir.
Now, when you open this, now you see this side has real, this side has imaginary. This side has real, this is imaginary, real, imaginary. But this is the function we want to transform. We want to make sure that one is a function of the other. So in this case, we replace W with what? U plus what? U plus IV. And then in this case too, we replace Z. We replace Z. That is what happened. We replace Z, which I said everywhere you see Z, you put X plus I. You put it here, you put it here. So when you open this, you're going to get this. When you open this bracket and open this bracket, you're going to get this. So at this stage, you realize that there is I here, there is I here. All the I's, you take it one side, and those ones that does not have I, you take the one side. So if you see this one, there is no I, there is no I, there is no I. So all this one that does not have I, we call them the real part of the equation. All those one that has I, we call them imaginary part of the equation. So if you take this imaginary part, you're going to see that you're going to have 2I plus xy minus iy. So if you now factor out the i's, right, you put I outside, you're going to have 2xy minus y. Then this other side, you see that this is x squared minus y squared minus x squared. You bring them one place. So to make life easy, we take all the x before, x minus y. Now, what do? We have to equate the right-hand side to the left-hand side. So in this case, you say u here has nothing to do with I. So all u will be equal to all the family that does not have i's. So this u is equal to, that is why we say u is equal to all the family that is independent of I. Then v has I. So we take v to be equal to all the side section that has to do with I. That is why we say v is now this. Okay, v now is this and u is this. In that case, we have been able to move our first step ahead. Now the next thing is, if we give you z, because we have given you this relation now. Now, if we say z is equal to 2 plus 3, okay, find W. If z is equal to 2 plus 3, find W. In that case, you know that I said anytime you see z, you must make sure it is in x and y. So in that case, your 2 here is x, your 3 here is y. That is why we say x is equal to 2, y is equal to 3. Then we go to your W. W is what? U and v. So already we have our u here, which is a function of x and y. We have our v, which is also a function of x and y. Now we have our x here given to you. We have our y given to you. So we just substitute. So if we substitute, we're going to get our u to be what? You see, our x is 2, our y is 3. So you come here, you put 2 here, you put 2 here, you put 3 here. This one is square. This one is square. So if you square this, you get 4 minus 2. You square this, you get 9. So when you add all this, you get minus 7. So what is your u? U is minus 7. Then the same thing, you come here, you put what? 2. This one, you put 3. This one, you put 3. Okay? So you realize that this times this is 4 times 3 is 12, which is this 12, and then minus 3 is this. So you have 9. So what is your u? U is minus 7, and then your v is 9. So in that case, your w, which is always a function of u and v, you put for v u. What is your u? Minus 7. What is your v? 9. So what is your w? Your w now becomes what you see here.
Yes, sir.
Thank you. Now, so I mean, when z is equal to 2 minus I. So how do we solve this problem? Somebody said it correctly, but for the first thing we have to do is we have to first introduce w, which is in terms of u and I. Then we have to introduce x, which is, I mean z, which is a form of x plus what? Iy. And then after we do that, we will now use for the value for x, where x is equal to 2, y is equal to minus 1, and then we'll solve it, right? So let's just make life easy. So w is defined for all z except when z is equal to this. That one is easy. Now, what we're going to do is we substitute for w. W is u plus I v. Then it is 1 all over z. And then we say z is this. Is that clear? Now, anytime if you see um, a function in this form, if you want to eliminate the I, you do the conjugate. And the conjugate is the negative of it. So if this is x plus this, then the conjugate will be x minus. So why do we do that? Because we want to separate it from the imaginary and the real. And why are we doing that? You see, if you take this divided by this is 1. So it's like you do not do anything to this equation. So when you take this and if you take this multiplied by the imaginary, it's just like take this and this square. That is all. So that is the first step we have done. The next thing we are going to do is now we're going to take the u and the I. In this case, the u will be x divided by x squared plus y, because this has nothing to do with I, this section. This is what? The u. And then the v now will have to do with everything that has to do with what? The I. So it is this section, right? So in that case, all of you know how we got our u and how we got our v. The next thing is, if z is this, then our x will be that, and then our y will be minus 1, right? And then in that case, if you do it here, this one is 2 square plus minus 1 square, which will give you what? 5. Okay? That is all of them. The denominator is 5. The denominator here is 5. So what happened? U is what? I mean, x, according to this equation, is 2. So it's 2 over 5. And then according to this equation, y is what? Y is equal to minus 1. So equal to minus 1 all over 5. So now you combine. What is w? U plus, I mean, u and v. W is always u and v. Okay? W, as we already see, is u plus iv. So you put everything together.